Okay, so today we are going to simplify square roots, and we are going to rewrite. We're going to rewrite radicals in exponential form and vice versa. So it should be a very simple lesson, so just pay attention. You're going to be getting two papers today, but the top one was meant for me to do as notes with you, so please save it, okay? Don't lose it. And the second one is the actual practice that you were going to do with your partners, and then whatever you don't finish it's for homework, okay? So I'm just going to do practice problems with you, and then you go ahead and try it out and try the second worksheet on your own. And this is going to be the same lesson for Tuesday and Wednesday as well. So please make sure you watch this video as much as possible if you need to. Okay, so let's begin. When I mean simplify square roots, I mean, for example, if you have, let me put the cursor here, the square root of, say, 25. All right. So the square root of 25, you have to think of what number times itself gives you 25. And it's got to be the same number, obviously. So then all of you, or most of you, will know that the square root of 25 equals 5. Okay? Because 5 times 5 equals 25. That's easy because it's a perfect square number. That means that I can think of one number and it's a nice little answer. I get a whole number, okay? But sometimes you get problems like, what is the square root of 28? And well, I can't think of a number that gives me exactly 28. For example, we already know 5 times 5 is 25. If I do 6 times 6, because remember, it's got to be the same thing. Okay, so you can't be like, oh, miss, 7 times 4 is 28. But 7 and 4 are different numbers. You're thinking of that one number that you multiply times itself. So 5 times 5, 25. 6 times 6, 36. I'm already over. So this is not going to be a perfect square, but you have to be able to simplify it as much as you can. So this is where like your elementary lessons come into play. Okay, you have to remember your prime numbers. Okay, prime numbers, those numbers that only have two factors, one in themselves. And I don't know if you remember, but your prime numbers, well, at least the first few, okay, are 2, 3, 5, 7, 11, 13, 17, 19, and they go on. Okay, but if you can remember the first, what are the first 8, okay, you're going to be able to simplify square roots very easily, okay? So here's what you're going to have to do. Let me move this out of the way. Okay. Put this one over here. All right, so here's what you do, okay? Let me make it a little smaller. Okay. So you kind of start thinking to yourself, what times what gives me 28, okay? And I know I can't think of that one number, right? So just think of your multiplication tables. We know that 4 times 7 is 28, okay? Then you have to be able to keep breaking up the numbers as much as possible. For example, I can't break down 7 anymore because 7 is right here. It's a prime number. But the 4, I can keep breaking it down. What can I break 4 down? Now, you don't want to use ones, so stay away from 1. 1 times 4, no. Think of other factors. Well, 2 times 2. Okay? And you no longer have this one. Okay? So what are you left with? Let me change this. You're left with this. 2 which I can't break it down and even know even more because it's right here. Another 2. And then the 7 that I couldn't break up here. So then your final answer is going to be this. Square root. You see these? How they're the same? It's a pair. You got to take it out. What is this a pair of? It is a pair of 2s, so you were able to take out a 2. You don't take them both out. It's just what type of pair is it? Type 2. Okay. And what's left? The 7. That goes inside. So if you actually get a calculator and you type in square root of 28, enter, you're going to get some decimal. Now type in 2 square root of 7, and you're going to get the same answer. So those are it, except this is in simplest form and this is not. So that's one way to think about it, to kind of just break them down until you can't anymore and until you're left with only prime numbers. That's it. You stop. Okay. Here's another way to break it down. Okay. Let me create another problem. So let's say I have the square root of, I don't know, say 200. Okay, square root of 200. What you can do, and right now I can't really think, so I will tell you what the method is called. But basically what you do is this. You kind of write it like this. Get the 200. And it's crucial that you know your prime numbers. So you're going to ask yourself, what's my first prime number? 2, right? You're always going to start with the first prime number. And you're going to see if you can divide 200 by 2. Can we? Well, sure, because 200 is even. So yeah. So 200 divided by 2 is 100. So then you put 100 here. And you don't move on. You keep asking yourself, can I keep dividing by that 2? And the answer is yes. 100 divided by 2 is 50. Can you keep dividing 50 by 2? You sure can. So 50 divided by 2 is 25. Can I keep dividing by 2? Well, no, because 25 is odd. Okay, so then it's time to look at the next prime number, 3. Can I divide 25 by 3? No, let's see, 25 divided by 3, no, because 3 times 8 is 24, no. Okay, what's my next prime number? Well, it's a 5. Can I divide 25 by 5? Yes, I can. And I'm left with 5. Okay, can I keep dividing 5 by 5? Yes, I can, because 5 divided by 5 is 1. And now you know you're done. Why? Because you are left with a 1 down here at the bottom. When you're left with a 1, that's telling you, hey, stop, you got your answer, okay? So how do you write your answer? Let me show you. You look at the outside, okay? You look at the outside and you ask yourself, did I find any pairs like over here on the first example? Yes, you have a pair of 2s right here and then a pair of 5s out here. So what type did you find? You found a pair of 2s times, you have to always times, what's the other type you found? You found a type of 5. And what are you left with? Well, this lonesome little 2 that did not have a partner, he is the one that goes back inside. So then you have to, kind of rewrite this. We know that 2 times 5 is 10. So you put 10 square root, 10 square root of 2. This is your final answer. Okay, so these are 2 examples that I think you can use. Okay, keep writing it or keep watching this as much as you can, as many times as you need to, and kind of try it out. Okay, whether it's the breaking up your number until you cannot break them down because you're left with prime numbers, or taking the first prime number and dividing that number by 2 as many times as you can, then by 3s as many times as you can, then by 5s and by 7 until you're left with a 1, and then you grab your pairs, multiply them. Notice I didn't get 2 times 2 times 5. No, it's only 1, 2, that you multiply. Okay, and then try it out. Okay, so that is the first part of the lesson. The second part is writing exponentials or writing radicals in exponential form. Oops, and I erased my prime numbers. That's okay, we don't need them anymore. Okay, so you write radicals in exponential form. For example, this is super easy, okay? This is probably the easiest lesson we're ever going to go over. So let's say you have the square root of 3. I want to write it in exponential. So I want to write it as a number that has a little exponent, right? So here's what you do. You see this one? What's inside? Okay? You're just going to write it. So you write a 3. Now, a square root, square, I don't know if you know, but a square is a little 2. Okay? But they don't like to put it because they assume, I guess, that you know square is the little 2. So what exponent am I going to use? Well, 3, if you don't see an exponent on it, remember, it's because it's a 1, right? So you put that on top over the 2. So what's inside goes to the top. What's outside goes to the bottom. Top in, bottom out. Okay? Let's do another one. Say I have the square root of 8. So you write the big number. It's being raised to the 1, right? Because I don't see a number. So 1 over, and square means 2. Okay. Now I know the question's going to be, is it always going to be to the 1/2? Is it always going to be to the 1/2? Well, not necessarily. What if you had, because for the square root, they're the only ones that they don't like to write it for, okay? For everybody else, they have to write it. So for example, if I want to find the cube root, then it'll look like this, okay? So if you see that and say now you have like 8 squared, what would that equal? Well, you put the big number. Whatever's inside goes on top. And then whatever's on the outside goes on the bottom. And there you have it. Now, this works backwards as well. What if I gave you something that looks like this? 7 to the, I don't know, 4 over 3. Oops. Then here's what you do. You draw a radical. The big number goes inside. Top goes in. Bottom goes out. And notice I made the 4 kind of small. It's an exponent, so you don't want to write it super big because then it looks like a 74. Okay? So top in, bottom out. Now, how about if I had this? 9 raised to the 1/2. What is that going to equal? You put the 9, top in. Oh, it's a 1. They're the ones that they don't like to put. Okay. And then the 2. Oh, it's a square root. Oh, they don't like to put it either. So, I mean, technically you could do that and I won't count it wrong, right? But on star, it would just be square root of 9 because the 1 insides and the square for the square root, they don't like to put. It's understood it's there. Okay, so this is writing radicals in exponential form and vice versa. Okay, so hopefully you can use this video as much as you can and try the handout out. Remember, the first handout is notes. I will do those when I get back with you. And then try the second handout, please. And watch this video at home as well. Help each other out, okay? And I will see you soon.